Alright, for this video, we're going to begin to go over the transformations for the 8 basic shapes that we looked at. Most important thing is when you're given the equation, you have to know what the basic shape is. Whether it's a parabola, an S shape, whether it looks like the Atari shape, or it's a semicircle, you have to know that right away. Now, we're basically going to go over the front and the back side. The front side, you can see, it's when you have here, it's saying A. A means the leading coefficient. If you basically have the same exact functions that we've been working with, the same basic shapes, and you put it in -1, the graph basically just flips over the x-axis. And the key part in the directions here is it says the graph is upside down. And you can kind of see here, you have x squared, you have the parabola, and then basically when you put a negative in front right there, it just flips. And it looks like this, which is what you get there. Okay, x cubed, this flips, so this bottom part right here flips up like this. This part right here flips down, so this is what your graph looks like, and that's what you get right there. Okay, the 1 over x, now this is where you're going to get a VA and an HA. The HA is y equals 0. The VA is x equals 0, because you can never divide by 0. That's still going to be the same. You're not changing that at all. But the shapes, you just flip them over. So the part where you have this 1, 1, that flips over and is down here in the bottom right. And the graph that you have bottom left, that flips over and becomes top left. So in the blue, that's what it looks like, and that's what you get here. Now, if you're not sure, you can always make an XY chart and plug numbers in, and you'll see when you plug numbers in that it kind of confirms that they basically just flip and the graph turns upside down over the x-axis. Okay, let's look at the examples down low. Okay, we do the examples down low. Okay, we look at these. Alright, let's go -x. Now this is an easy one. We really don't have to concern ourselves with how it flips. -x, the y-intercept is at 0. And our slope is -1, so we could go up 1 to the left 1. So we have this point, and then we know the line just goes down left to right. Okay, next one you have -√x. Now, in the blue, I'm going to graph just +√x. This is +√x right here. Now that I have -√x, I'm going to put this graph in green so you can see the difference. This just flips over the x-axis. This is what it looks like. So the part in the green, that's the graph. Now the next one, the negative absolute value of x. In blue, I'm going to put where it's just the absolute value of x. This is the V shape. Now it's important, this is the vertex of the V shape, that's at 0, 0, and then you just go to the right one and up 1. So that's at 1, 1. Same thing, you would go to the left one of the vertex and up 1. This point would be at -1, 1. And if I just put negative in front of the absolute value, it just flips over the x-axis. And this is what our graph looks like. So again, the green, that's the shape that you want. Okay, next one, I'm just going to go right to the graph. Since you just have 1 here, you take the square root of 1, that's 1, that's your radius. So you're still going to get your origin is still the center of the semicircle. If you put in +1, you're still going to get 0. If you put in -1, you're still going to get 0. But when you put in 0, you get the square root of 1, which is 1. But then you have the negative on the outside. This flips over. So your graph looks something like this. My drawing here is awful. But the main point here is at 0, you get -1, not +1. So it flips over. Okay, the last one. This is where you get the Atari shape. Now, I'm just going to put this off to the side. The Atari shape looks like this. So now I put the negative in, it's going to flip, and this is what it's going to look like. They're both going to be in the bottom. So you're still going to get, I'm going to put the little dotted lines here. You're still going to get y equals 0 and x equals 0 for the VA and HA, but your graphs are going to look like this. If you put in 1, you're going to get -1. So let's go 1, -1 right there. And that's really the only point you need, so that's 1, -1. And then if you put -1 in, you're going to get the same thing. You're going to get -1. So you're going to get this graph. So this ordered pair would be negative 1, negative 1. Alright, so that's pretty much it. The first page is pretty easy. If you just put a negative in front, it flips over the x-axis. Okay, let's look at the back side of the page. This is where the graphs either get skinnier or wider. Okay, so for this is where the graphs get skinnier or wider. Here's the main point here. If the graph gets skinnier, let's see here, generally speaking, if A is bigger than 1, meaning if it's bigger than the absolute value of 1, the graph rises or falls more rapidly, it gets skinnier. This is a case right here. Right, that's bigger than 1. 2x squared gets skinnier. Alright, so this is, you have the same vertex, but now you go to the right one, but you go up 2. So now you're at 1, 2, that's a width point. You can go to the left one and go up 2, so now you're at negative 1, 2. Where normally, you just go to the left one and up 1, now it gets skinnier. Now the other part right here is this. Basically, if A is a fraction that's less than 1, the graph rises slower, so now it's going to get wider. Here's an example right here. You have the 1/2 in front. So now for this, it basically gets wider. You still get this same middle point, but you want to get width points. So now you're going to go to the right one, but only up 1/2. And then from the other middle point, you go to the left one and down 1/2. Again, you can get those using the XY chart. So that S curve gets wider. The next one, it's going to get wider. The 1 over 3x, you can think of it like this, 1 over x. Well, that's going to give you the shape where you have it in the boomerangs in top right, bottom left, but it gets wider. So from the origin, you go to the right one, but only up 1/3. So you get that point 1 1/3. Then from the origin, you go to the left one, down 1/3. So you get this point right there. So that graph gets a little bit wider. Okay, I'm only going to look at some of these examples. I'm not going to do all of these. The ones that I don't do, that means that you have to do them on your own. Let's see here. Let's look at, let's do the first one. Okay, now I know this is the first one right here. Let's make this a little bit bigger. Let's focus in on this. Oops. Alright, let's focus in on this, the 1/3 root x. Now, here's the general shape. I know, I'll draw a little sketch right there. There's the general shape, square root of x. Since I have 1/3, it means it's going to go up slower, so it's not going to rise as rapidly. So I can still put in 0, because square root of 0 is 0, and times 1/3 is still 0. But then when I go up, when I go to the right one, I'm only going to go up 1/3. So it's only going to go up like right here. Another good point to put in is 4. So let's go 2, 3, 4. Square root of 4 is 2, and then when you times it by 1/3, you get 2/3. So this is only going to go up here to 2/3. So it just goes up a lot slower. So if I wanted to put ordered pairs, this here is 4 2/3. So this kind of gives me the width points. This one here is 1 1/3 for that point right there. Okay, let's see what else. What other problem can we do here? Let's pick and choose here. Which one do we want to do? Okay, let's do the absolute value one right here. Let's focus on this. So this is absolute value. You have the 1/2 in front. This is going to be the same thing. We have 1/2, so it's going to get wider. I know this general shape looks like this, but now it's just going to get wider. I still have the same vertex as 0, 0. But now I can go to the right one, but I'm only going to go up 1/2. I can go to the left one, but I only go up 1/2. So this V shape just gets wider. The ordered pairs, this ordered pair would be 1 1/2. This ordered pair to the left would be negative 1, positive 1/2. Okay, let's do one more. Okay, let's do one where it gets skinnier here. Let's do the last one, y equals 3x squared. Now normally, x squared, this is our shape. Now what's going to happen, this is going to get skinnier, so it's probably going to look something like this. It's going to get more narrow. Probably going to look something like that. So I'm going to get the same vertex, it's going to be at 0, 0. But now, since this is 3, when I go to the right one and to the left one, it's going to go up 3. So let's go 1, 2, 3. So I go up 1. So I go, excuse me, I go to the right one, up 3. I go to the left one, I go up 3. So this just gets more narrow, it gets skinnier. That's your graph right there. Try to make it a U shape. So this ordered pair here would be 1, 3. And you can check it by plugging them in an XY chart. And over here you get negative 1, 3. So it goes up quicker. Okay, all the other ones on this side that we didn't do, you should do that. That's part of your homework right now. So once you're done this video, finish all these problems that we haven't done right now.